Hello and welcome to yet another lecture in our Prolog Essentials series. It should be live now. Okay, cool. So I'm going to assume we're on. So we're a little behind in the class, so I decided I would kind of abbreviate our discussion of pensions. First of all, I'm going to find out, can people hear me? So I'm going to talk about pensions this evening, and then that's what we'll do with pensions. Okay, cool. All right. So, Prolog's pretty nifty, and we've seen it do a lot of cool things, but distributed programming? Yeah, distributed programming. Fellow on is Torbjørn Lager, professor at the University of Gothenburg, and fellow on the bottom is Jan Weilemacher, of course, and they built, as a collaborative thing, this is a system for doing distributed and Prolog and a bit more. So this is Bob, and Bob has some queries he wants to make from all these different machines, and they've each got a different API, and he's kind of talking over a whatever Bob's programming and whatever Bob's, and the servers are in whatever they're in. But in between, we know what it is. It's HTTP, which is a pretty minimal language. So, so this is kind of a pain in the butt, as anybody who's a job can tell you. How could we make this easier for Bob? Suppose we've got a Prolog server, and we got a whole bunch of data and some rules that hand it back. So here's an option. We could give Bob shell access on our machine, and then Bob could just spool up an interactor and have the same access server does. Well, that's okay if you've only got one Bob, and if your machine's online all the time, and then most importantly, if you trust Bob. And that's completely unworkable if you want to serve this data out to millions of random unknown on the internet. So, this is basically Torbjørn is. Prolog, in Java, if you have part of a program, you just don't have much. You've got unresolved linking. But Prolog, yeah, if you're a Prolog program, you just have a slightly different program, right? I remove some facts, and then the program's still valid. It just doesn't have those facts anymore. So, weirdly enough, you can perform operations on the Prolog knowledge base. So Torbjørn says, what if I gave Bob an interactor, but only for a subset, this orange subset? And, for example, shell, which, if you haven't run into it, is a performs, shells out a command, or halt, or open, or any of these things that you really don't want Bob to have access to. You just don't put them in the orange part of the data of the knowledge base. Then Bob, or Bob's program, can call up, and we'll have some protocol, the thick line, and Bob can say, hey, make me an interactor and run this query in this subset. Something rubs on my microphone. Okay. Hang on. Tell me if that didn't cure it, because I just moved my microphone. Now, so, to get really crazy, Bob could have a pension master make slave pensions on I hope people are seeing my cursor, on the, hang on, I'm going to actually make sure, because otherwise this will be hard to follow. Yeah, it's there. So Bob can call up a couple of different applications on one server and make pensions there, and then one over on this other server, and have a whole bunch of these little slave pensions working. And in fact, gosh, here's some pension that somebody made, and made another pension on another server. So we have these whole little ecosystems of pensions. By the way, I'm going to assume nobody that my microphone problems could cured. Okay, so now down here we've got a web page, and hey, this is just an HTTP call to this pension protocol is on top of HTTP. So, gosh, we could do it from a web page. So, yep, you can do it from a web page, which is awfully nifty. Somebody is trying to talk to me. I've got a student. Okay. Sorry about that. So, okay, so where we were was we said we have these networks, and okay, here's the whole Prolog. Already know we can't do that. Because that would include all these unsafe things. So, a subset, and call those the sandbox safe set. And hey, we've got sandboxing. Now, that set is set up by module sandbox, so you don't have to worry about what's in there. And Bob can call member and so on, and Bob can have a and Bob can have a complete set of, basically the whole power of Prolog inside the sandbox. By the way, you can make a sandbox and have more than one query, so Bob could even store state over here. Well, that's great. That's actually how Swish works. Except, there are other things we want Bob to be able to do in our and offer. We might offer the user things that wouldn't be safe. That are our own code that will give, for example, access to our database. And of course, it's got to check that you've got access to the rows that you're for, and so on. Or do something like, if you're going to allow the user to update their thumbnail image, then you need to store a file with their PNG. So all of that is going to end up in some API that you can glue on to your sandbox. Hey, happy? Anybody confused? I send query over, and of course query can be an arbitrarily complicated Prolog program. It's run over here, and the results get sent back non-deterministically. Not seeing anybody talking to me, so I'm going to keep going. Okay, well, that's all great, except, just doing this is going to open you up to security holes. And that would not be good, because programmers are busy. You might accidentally put something in the that you weren't certain was clean. Now, usually, an API is kind of like a funnel. You'll have various end-user APIs, and then they all come down to some lower stuff, and there's often less of that. So, okay, so we will analyze the code, and we will just remove anything that we think is unsafe. That is pending. Except you still have to have some way of, like I say, writing that thumbnail file out, and open you obviously don't want to have safe. So, a way of marking things as safe. And I just discovered they changed how they did that right before this talk. So by whitelisting. And in fact, it's a process of, you give it a white, how do you determine what's safe? It walks the code. And it basically, if you do something like use univ to assemble some predicate and then you call on that, or to assemble some term and then do call on that, it's not going to let you do that just because it doesn't know what you're doing. So, it's pretty conservative in that sense. You have to be pretty explicit and say, look, I know this looks like it's dangerous, but it's okay. But you don't actually are going to do something dangerous. So it reduces your attack surface area. And that is, you might, for example, when you come in, need to also have a little bit of extra code, basically. And in theory, you could pass that with it, but oftentimes, is this the reason you mentioned putting Prolog behind Apache? Putting Prolog behind Apache is just accepting the reality that there are literally millions of Apache servers running, and the people who work on Apache are very good at web security and very good at being DDoS resistant and very good at handling odd protocol things, and that's not something you want to kind of roll your own. So putting your Prolog behind Apache just is a real safety issue. If you find if there is a hole in the Penguin security, then yes, that's a security issue. We've found one once. Something got included in the orange area that shouldn't have. So, I mean, just because you're behind Apache, if you can still call, open, then you can read any file that the user that started the Prolog VM access to. Of course, so back to the last piece here. We have this chunk that can be passed in to add on to your sandbox safe, just as basically as a convenience. Yeah, I will share the slide deck definitely. It's already on the out there. I will share the link after the talk. But of course, we don't want to allow people to pass, so we punch that out. And there's no override. Okay. So altogether, this is the net knowledge base that you get. Querying. I tell you what, I'm going to handle the querying by live coding because this is quite out of date. Myself turn to large fonts. Large fonts. Okay. So hope that's big enough. Here we have what, if you're up to date, is probably you'll recognize as a minimal web server. Since we're serving over HTTP, we have to have HTTP server running. And then we include pensions and we have a and then we're going to declare an application and use module into the application. You might want to have more than one application running on a server, so there's a name for each application, and that determines what gets added in that right-hand bump. Okay, and then let's see what we added. Well, this is kind of a silly little file that has chihuahuas. And so I have bark and I have growl. So if I do So I can now just use Pension RPC and do bark. And if I look on my other console, it's going to bark. So I'm actually over here in one terminal, and this could be anywhere on the net that can reach my machine. I, of course, am not on a public, I'm not reachable from the outside world, if I were. And it runs over here. In the other terminal, it's printing out. Well, kind of interesting. So what about non-determinism? Surely we don't do that. What happens if I do this and call member? Pension RPC is itself non-deterministic. So this is kind of cool. We've a client that can run code on another machine. Now, well, that's great as long as we're running Prolog on both ends, but what if we're not running Prolog on the client? We got to run it on the server, obviously, because we execute Prolog there. Well, if you're in Java or Ruby or Node or in a browser there, and I think there's a Python client. And if there isn't a client for your language, it's not actually very hard to write the client. So, so you can build a, it's from pretty much any language. Well, now here's the part that wasn't here. Whoop, hang on, I gotta make this bigger. Evil shells out and runs the little cheese application that takes a screenshot, or takes a camera shot. So, can we call that? Let's try calling evil. Nope, won't let us do that. Well, that's kind of weird because evil and bark look just the same, except evil itself calls something. So what's the difference? Well, Prolog, the pension system, has looked at what evil calls and discovered it calls shell. So now, at this point, so questions before I go on. I'm going to stop here because I've been just like plowing it. Okay, I'm not seeing any questions, so I think I'll just plow on. All right, at this point in the lecture, I should be demonstrating how to safe primitive something. Make that. Hang on, I'm going to back up to my slide here. Remember, this littlest bump is the things you could mark safe. And I was going to demonstrate how to do that, but I discovered that it's been changed since the last time I did, and I don't know what the new recipe is. So, so I'm not going to do that. All right. Okay, well, that's great if we're coming from Prolog. Let's see what happens if we're coming from JavaScript. you have to include the pension.js file that is provided with the distribution, and you serve that, and no pictures for us. I'm not certain what is no pictures. I don't know what you mean. Sorry. So, okay. Whoop. Oh, yeah. I can't mark cheese as safe, hence no pictures for us. Yeah, it's not going to mark. I'm not going to be able to run cheese. So, okay. So, well, that's great. But hey, it sounds really interesting that you could do this from JavaScript in the browser. Yeah. So, pensions.js, and you include a and then you're going to need some JavaScript. You can make a new pension object, and then this is pretty typical JavaScript programming, right? I will get this new handle. It's going to call back when it finishes creating, and then I will call ask, and I will get some predicate, and then I can tell it a template, which actually just tells me what to get out of the query to put in the data, and then that's going to come out, and I can shove it into a web page. I said back here you could add your own stuff, and you can do that by property that is source or something. But the easier way to do it is that if you make a script of type text x Prolog, it will go along with your pension. This is pretty nifty because it gets really close to having Prolog. Should that be commas in the Prolog code? On the right-hand side is not Prolog code, it's Java. On the left-hand side, no, those are facts. They're just improperly indented. Sorry, I brought this in from to LibreOffice from PowerPoint, and somehow my indenting got messed up right there. Those are just facts. So the idea is I'm going to query Q sub x, and then P sub x, and then A, B, and C. Okay. All right. So let's see here. And then yeah, we've seen that one already. Prolog at one point was doing like I/O, because we didn't quite know what to do if you did I/O, and that idea is pretty much dead. Just basically, if you do I/O, as we saw, you're going to get I/O on the console. And yeah, I/O on the console, it's questionable whether that ought to be safe, but Jan's argument is it makes debug simpler, that it's worth allowing your pension to spam the console. Okay. All right, so that's pretty much. Let's see. Nope, that's the part that's broken. That's part. Okay. Well, some other niftiness of this. Suppose I'm dealing with RDF. Yes, the JavaScript handler actually gets a more flag, which is true if there's a choice point remaining. If there isn't, that'll be false. And then if you get the more, you're kind of expected to call back. You can call stop, which will end the query. It's a little breaking the internet protocol in that you've got state over on the server. Well, we do that all the time, you know. So, but and it's actually complete HTTP calls. It's not some weird WebSocket thing. Okay, so suppose I need to do a bunch of queries kind of everywhere. This is really handy if I'm serving a bunch of via a bunch of different servers, then I can make a federated query just like this, and this thing will do the appropriate backtracking and run just like a Sparkle query. Okay, let's see. This is going to be a little dated, but okay, where are we going? Well, we're there. This is a talk from 2014, and now you'll recognize this is an early version of Swish. This is how Swish works. You submit a Swish query, and all it does is make a penguin and server using the source thing to send all your sources. So we built a bunch of stuff. I was very much into the idea of making a truly real-time collaborative environments at that time, and so I built this collaborative diagram editor. And that's an idea that didn't seem to go anywhere. Oh, I should tell you, this site down below is at, I'll type it in here. It's at penguinsweprolog.org, and that is the only place the JavaScript documentation exists, which is not the most findable thing on it. Where it is, and he doesn't win all of the battles. So it's kind of where we've come in the last 6 years since this talk was originally made. Swish has moved from this kind of rudimentary version to the full-featured thing that we have now, and now, especially if you're in the linked open data world, doing things with penguins has become pretty straightforward. Has become pretty common. Laundromat, for example, which is now becoming Triply, has will serve over penguins, so you can get kind of a clean version of the whole semantic web, and send your query over, run it on their machine instead of having to transport gigs of data back and forth. So that's penguins, and they're useful for lots of things. They do make web programming, in particular, quite a bit. Because you can get essentially non-deterministic queries, and of course that that kind of non-deterministic thing. Bizarrely, JavaScript on the web is kind of non-deterministic in that if you think about like jQuery selectors, those are actually kind of they'll pick as many things as they match. So so now we have Tau Prolog, and I think what's going to is Penguins and Tau Prolog and is going to result in some really interesting kind of declarative end-to-end Prolog all the way web programming, and then out of that, Prolog's really introspectable. You know, you can, I mean, like, look at the sandbox. You know, you can look at the code and see if it's safe. Also look at the code and say, does this really need to go to the server? And if it doesn't, then we'll just run it on the browser. And we can look at it and go, does that really need to go to the browser? And if not, then hey, we can, you know, we can opt that path out and have and slowly get out of the whole thing of having to do web programming. And that's a real win. So that's kind of where I hope we're headed. I must confess, I probably would be headed faster if I was actively coding on that, but I'm not certain I'm at a point where I know what I want to write. Okay, are there more questions about this? Otherwise, I think we'll just be a little short tonight. Are there other questions people need to sort of pop up a terminal and answer while we're on? If not, I'll let you go early. Can you still do the Penguins exercise? Sure. The Penguins exercise, I think, is just was just going to be to watch the 2014 Strange Loop talk, and I thought it would be more beneficial to use the lecture to kind of update it because this stuff is quite long in the tooth. Norbert, it's a standard HTTP connection because always originated by the client. I call up and I say, hi, make me a penguin, and it hands me the ID, and then I call up and say, ask penguin ID such and such this query, and it comes back with a response and whether to call it again, and then I'll say, okay, give me the next solution to such and such, and then when I get tired of getting solutions, I can say stop or destroy the penguin. But that's all done through basically a REST interface. So the penguin is treated as a resource on the server. Each result is a connection. Each result after the first one, since so often you're actually expecting to be det, to be deterministic, there is a short form where you can say ask as a JSON, field in the call to create, and you can say destroy the penguin after you're done. So if you get a deterministic response, it will not keep the pension around. As in create, ask, get a result, and destroy in one HTTP request. But yeah, if you're going to call member and get a bunch of responses, you're going to have one for the create, the first ask, then one for every member afterwards, and then if you don't set it to auto destroy, you're going to have to destroy it at some point. Of course, what you call an answer, I mean, you can do set of on the other side. If you want all the answers, just do set of. It's available. Okay. Not seeing more questions. I think I'll just let you go a bit early tonight. Oh, there were other questions about. Hang on. Oh, I see. Okay. You're right. Thanks for calling me on that. You said Swish has come a long way. Is that because of new pensions features or some other reason? That's some other reason. That's basically because there's been a lot of work on the, primarily the back end, still relatively straightforward. It just serves. The only thing we've added on the back end has been the file system, which is some kind of mini Git thing, and oh, Jan actually just got back to me. Hang on. Okay, and it turns out I just made a boneheaded. Okay, how does the performance compare to Prolog on the machine? Well, you're going to have an HTTP request getting over there, and then you're just running standard Prolog. It does a code walk first, but usually pensions requests are usually small. Okay, and Jan says that nothing has changed for ages, so woohoo, I think I'll go back and cover this then. I had the impression something had changed. Okay, so that answers those. Doing the pensions exercise. I think the pensions exercise was basically going to be watch the 2014 version. Okay, I'm going to go back here then and see if we can get this going. Jan just pointed out my boneheaded mistake, basically. Okay. And Jan says, hey, and here's my boneheaded mistake, yeah. Okay. And there it is. All right. Let me see if I can. I'm not going to torch you with watching me. Or oh, okay. All right, it's working. So now let me go walk through this. So I guess girl. Yay. Okay. Here's the way you do this. You will make yourself an application. You actually can do this in the sandbox, I believe, but in this case, but it's probably better to make a specific application by calling pension application. And then use module, your API, which is chihuahuas in this case, into the application's name. And otherwise the application must not be the name of any module. So we're going to then, this is a really weird syntax, I know. This is use module on a different than the one you're in, which is definitely in the Prolog is a big buzzsaw with no guards space. But yeah, you can import something into somebody else's module. Okay. So here's chihuahuas, and we already saw the bark that bark works, but not evil, but evil and not evil don't work. Call shell. So let's say we want to allow not evil to be accessed. Whatever it's shelling out is something that we know, we're okay with having cheese launched. So, okay, you have to, this is a multi-file predicate. We didn't cover multi-file predicates, but this basically says, hey, the clauses of this predicate are defined over multiple files. And this is a common way of installing hooks in Prolog. And then I'm going to call sandbox safe primitive and tell it that not evil is a is safe to call. And now I can call not evil and is cheese. Okay, so thank goodness. Okay, questions about that part of it? If not, I think we're done. And I'm thanking Jan if you're wondering why I'm typing. Anybody else got a question then? If not, I think we're thank you all. Sorry about the confusion. Oops, several people are typing. No more questions. Okay. I'll wait till the questions come in for comments. Woohoo! Talking about cheeses. Earlier we talked about salmon. What up in cheeses? Okay, thanks everybody. Josh, I see you have a question waiting for me. I'll get to you as soon as I go apologize to Jan. Okay, thanks everybody. Bye-bye.